So good afternoon, everyone. Today we're talking about the full wave rectifier. The full wave rectifier. So this is what we'll be talking about today. I might actually just take on the rectifier alone, because getting into the full extent of the full wave rectifier might require a lot more time. But before we go into the full wave, what really a full wave rectifier is, normally in some places this full wave rectifier is also known as diode, but the full name is full wave rectifier. So before we can take on what a rectifier is, we need to first know what is a diode. Now, I know, see, I go even the ad say they disturb me for this video, but I don't need your disturbance. So, what is a diode? A diode is an electronic component that allows electricity to pass or to flow in only one direction, only forward. When electricity comes in reverse, let's just say this is forward, so it can only allow electricity to go through like this, but if electricity tries to come in the other direction, it blocks it, so it only allow electricity to come forward. I have from this circuit, I just cut it from, I don't know, I have a diode here. This is a typical example of diode. Now, one thing you should know is that this diode you are seeing here, there are actually different types of diode. They can come in different form. The one you are seeing here is the PN junction diode. We also have the Zener diode. Though that one actually allows electricity to pass in both directions, whether forward or reverse. We have the LED, light emitting diode, that we normally know as the bulb, Schottky diode, photo diode. A lot of them can actually go into all of them. So this is a diode. This is a diode, and we'll be talking about it because this is what is normally being used in rectifier, full wave rectifier, whatever you call it, or a diode. The image I have drawn here is the symbol for diode. So electricity can actually flow in this direction, but when electricity tries to come this way, it is blocked. So it is forward. When electricity tries to reverse, it blocks it. Now, when you are looking at a diode, how then do you know where electricity can flow to and where it cannot flow to? When you look at this diode now, you see that, let me place it very well. When you look at the diode, you see that there is something like a silver coating around this area. This junction here is known as the cathode. That is the negative side. So it is always marked with a stripe on the body, and you are seeing the stripe here. All these other areas are black. Then when you get up here, you get a stripe like a silver coating that is on the body. So that is the cathode, the negative side of the diode. Then this other side here is the positive side, the anode. So, and as we said before, diode is an electronic component that allows current to flow in one direction, in the forward direction, and when it reverses, it blocks the current. Now, how do you know whether the current can actually flow like this or it is going to flow the other way around? One thing you should know about this diode is that the negative part that is being marked with this kind of silver stripe here is it is the negative part, and it is the part that does not allow that does not allow, it is the part that does not allow current flow, while the positive part, when current comes from this direction, it can flow through here. But when current is in reverse, like for example it is coming from here now, when current goes up like this, it is blocked. So when you're looking at it with this, this now is serving like the stripe. It is serving as the stripe. Just look at it. While this is the positive part of the diode, and then this is the negative part. So when current comes, this now serving as the stripe will prevent this current from passing through. But then if current should come here, current will be able to flow in one direction and go straight. Now that is for diode. Diode is used to make a rectifier. What is this rectifier? A rectifier is actually a circuit. Some you might just see it like this, or others it has been enclosed, but it's always a circuit that converts an alternating current AC. It converts it to DC using these diodes. So with the help of this diode, a rectifier converts an AC to DC. Now how is it able to do that? Since diode always acts like a one-way valve, preventing electric current to pass in reverse. So now how is a diode able to how is it able to convert AC to DC? Well, as we have said before, I don't know how many times I've been saying this. Since a diode conducts only when it is forward, like only when it is from the positive side, since it allows the electric flow from the positive side to the negative side and blocks it when it reverses. We know that AC usually is not something that moves straight. It's not like a direct current, but it is something that is changing polarity. Like it has a positive and negative half cycle. The cycle like is not complete. For example, you might see it if this is, let's say, live neutral, it goes like this. It goes like this. So it is always changing. The life cycle is not always complete. It is always half. The positive and the negative are half cycle. Now what this diode will do now, it will selectively pass one half of this. It will selectively pass one half of this cycle and then block the other half, thereby converting it into DC. And we know our DC to be a voltage that is always constant and steady. Instead of having it cycle like this, you always see it in form of like a straight line. So when the diode takes half of this circle, and the circle I mean is this type of circle. So when it takes half of this circle, it will then pass one half of the circle and then block the other half. When it does that, it converts the AC that you see here to form a straight line. That is the DC, direct current. Now how is it being put into a circuit like this so that it is able to do something like that? Since we know this to be the sign for diodes. Now to have a full wave, to have a rectifier, you will need this diode in 4. This is 1, this is 2. Always make sure that they are in the same direction. So this is the second one. Then we'll have another one here. If this one is like this, then definitely the next diode that is to be here must be in the same direction in order for your circuit not to become something else. And the rain has started falling here, so whatever way it is, you take it like that. Now this is this connection of how all the diodes will be together. Now, how do you know where to put your live and where to put your neutral? Honestly, it might be a little bit tricky when it comes to this, but the first thing you do, or the first thing I normally do, this is the negative part of the diode, the ones that doesn't allow current to pass through. So you just take this side out, and it will be the DC minus, the negative side of the DC. Then you look for an area where we have 2 terminals like this of the diode that allow electricity to come through it. And when you look at it, which one? This is it. This one allow electricity to come through here, and this one also allow electricity to come through here. So you will take this one now, and this will become the DC positive. You are only left with 2 terminals. And when you look at it, if a current should come through here, if it goes here, it will be blocked. If it comes down here, it will pass through. A single wave of this current now here, when it passes through here, since the diodes can only take half of the wave and makes it to become one full DC, one full line of DC. So if the current, let us say the positive part of a positive part of AC current goes through here, when it passes here, normally it's supposed to go to wave, so it's supposed to be in form of wave. The first half wave that comes into here, it becomes one part of the DC wave. It might be the positive, it might be the negative, but since we have the 2 negative parts of the diodes here, the current, the pulsating current that will be coming from this direction will be the DC negative. Now for this other side, having the DC, one thing you should have in mind is that this is the DC part, for the positive of the DC, but since this is for AC, and the other terminal will also go to be in form of AC, normally you will not know if this is the positive part of the AC or this is the negative part of the AC. So the current coming in through this direction will come here, will flow through here, and the one coming through here will also flow through here. When the 2 current now meets, the half wave that both of them form will then become one single wave, a DC wave, creating the DC current that you know of. When current comes to this direction, you see that it is blocked. When the current comes to here, it is blocked. So this here is the positive part of the DC current. When current comes here in form of live and it comes in form of neutral, it creates half of this circle. The circle here is not complete. This is half, this is half. So when the currents come, it is then taken and then it is converted. One half of that current is taken and the other half is now blocked. It is then converted from that AC to the straight DC that we see here. In full rectifier, it is normally, before all these currents, there are sometimes that maybe the current might not be that smooth. If you see, sometimes they will just need to maybe add capacitors to it. When they add capacitors to it, they will now smooth out the waveform. And some might also add voltage regulators so that it will stable the DC output on what it is giving out. But the main thing is that the diode that we see here, it is what is used or formed, what is being used in order to form a rectifier, what converts AC to DC.